Welcome back to Easy as Pie, the channel that makes maths simple. If you're new to the channel, make sure you hit that subscribe button so you don't miss any new content. Today we'll be covering the Level 2 Mathematics Algebra paper, Question 2. Part A. Find x if log base x of 243 is equal to 5. So what we need to do here is rearrange this equation to get x on its own, and then we can put the value we get in the calculator, and that will be our answer. Typically when we're dealing with logs, we don't want to deal with a log unless it's log of base 10 or log of base e, where e is just a special number, sort of like pi, about 2.71. So how do we start this? We're going to need to get rid of that log first, so to do that, we'll just rewrite it out. Log base x of 243 is equal to 5. So to get rid of a log, what you need to do is raise it up to the power of its base. So the base for this log is x, so I need to raise it up to x. But because I'm doing this to the left hand side, I also have to do it to the right hand side to keep it balanced. What we have now is the x and the log base x will cancel, leaving me with the 243. And the other side will be x to the power of 5. Last step is to get rid of the power of 5, so we need to do a fifth root, or if we're dealing with powers, we need to take the right hand side to the power of 1/5, as that's the same as a fifth root, and then do this to the left hand side. What you notice is the 5 will times with the 1/5, just the power rule when you're in the brackets, and leave you with x to the power of 1, because 5 times 1/5 is 1. X to the power of 1 is just x. And we'll just chuck this in our calculator to see what x is equal to. So we'll go 243 to the power of 1 divided by 5, 1/5. And our answer for x is 3. And if you get that out, you've just got yourself an achieved. Find m if log base 3 of 4m minus 1 is equal to 2. Right, again, we're going to need to get rid of that log to start solving for m on its own. So what we need to do to both sides first is we're going to raise this to the power of 3 as its base is 3 to cancel it, and we have to do the same to the other side. What you'll see is that this will cancel with the log as it's its base, and you're left with 4m minus 1 on the left equals, and you've got 3 squared, which is just 9. From here, we'll add 1 to both sides, so I'm going to have 4m equals, and 9 plus 1 is 10, and I'm going to divide both sides by 4. So dividing this by 4, the 4's will cancel, then I have to divide this side by 4. So m is equal to 10 divided by 4, which can be written as 5 over 2 if you simplify, or 2.5 in decimal form. And this will get you an achieved for this question. Part C, find an expression for x in terms of w if 3 to the power of 4x plus 1 over 9 to the power of x equals 27 to the power of w over 3. Right, so basically what it's asking for is x in terms of w means the final answer will look something like x equals, and it'll have stuff with w in it, and that's when you know you've got the right solution there. So what we're going to do is we can use logs for this, but it's easier to do this other technique. I'm just going to show you. The first thing you notice is that 27, 9, and 3 are all powers of 3. So we're going to rewrite them all down in powers of 3. So I'm going to start with 9 to the power of x, and that can be written as 3 squared, because that's 9 to the power of x. And we know when we've got it in this form here, it's the same as just timesing the powers together, so that's 3 to the power of 2x. So what I've got there is 9 to the power of x is the same as 3 to the power of 2x. Now I'm going to look at 27 to the power of w over 3, which can be written as 27 is 3 cubed, so it's 27 to the power of w over 3, which equals, now just remember that that power of 3 is 3 over 1, because anything over 1 is still itself. So if we times these together, we times the top of the fraction, so we have, just looking at the fraction bit, we'd have 3w over, and 1 times 3 is 3, and the 3's cancel, so it's just w. So we have 3 to the power of w is the same as 27 to the power of w over 3. If we plug what we've got here back into our original, we'll see what we've come up with. So on the top there, we had 3 to the power of 4x plus 1 already. Instead of writing 9 to the power of x, I'm going to write 3 to the power of 2x, which we got up here. And that's equal to, and 27 to the power of w over 3 we said was 3 to the power of w. Right, so we're getting more simple here. The last thing we can do to help ourselves out is go, well, if we've got any, so if we had x to the power of n over x to the power of a, for example, we can simplify this to x to the n minus a. So you just subtract the powers and keep the base the same if you've got that situation, which we do because we've got 3 being the same. So we can rewrite that as 3 to the power of 4x plus 1 minus 2x equals 3 to the power of w. Just going to simplify that power down on the left there. So 4x and the minus 2x makes positive 2x. Then we've still got the plus 1. And that's equal to 3 to the power of w. Now what you notice on both sides is that they're both 3 as the base. So for these two things to be equal, because the bases are equal, the only condition that will make it equal is if this power here was equal to this power here, these two sides would be the same. So therefore, if 2x plus 1 was equal to w, the above would be true. Remember the question wanted x in terms of w, so we just have to rearrange to get x on its own. First I'm going to subtract 1 on both sides, so that'll leave me with 2x when I subtract 1, and subtracting 1 off w will give me w minus 1. And my last step, I'm going to divide by 2 to cancel out the 2's, but because I divided by 2 on the left, I have to divide by 2 on the right. And therefore x will equal w minus 1 over 2. Now I'm just going to go through a method of checking this, showing you how to check it's right. So we'll just go back to the original and we'll write it down again at the bottom. So 3 to the power of 4x plus 1. And it was over 9 to the power of x, and it equaled 27 w over 3. So just as it is important to get the answer, so this would get you the full marks here, it is important to check your work, because if you can check it, you're not gonna, you can go back and make sure that you're 100% correct, because if you check and it's wrong, at least you can go back and double check it. So I'm going to show you how to check it now. So we've got this relationship here, so if I pick a value for w, I can use this relationship to tell me what x should be if I use that w value. So just as an example, I'm going to pick, well, w is equal to 3. And if I plug w as 3 into here, that's going to say, well, x therefore has to be, now we've picked w to be 3 minus 1 over 2. So I'm just using this equation down here. And I've replaced the w with a 3, because that's what we've called it. And that's saying, well, x should therefore be 3 minus 1 is 2 over 2, which equals 1. Right, so when w is 3, x should be 1 according to our relationship. So if we check this with these two values we've just got, they should be the same. So on the top we're going to have 3 to the power of 4 multiplied by, now x was 1, plus 1 over 9 to the power of x, which is 1 in our case, and that should equal 27 to the power of w over 3, and our w is 3, so 3 over 3. And we'll just simplify that down a little bit. Well, actually, we can just chuck that in the calculator now and double check it. So let's chuck that in there. Right, so on the left hand side we've got 3 to the power of 4 times 1 plus 1 divided by 9 to the power of 1, which is 27, and on the right hand side we've got 27 to the power of 3 divided by 3, and we also get 27. So it's showing that with our relationship we got out for x and w, that both sides are equal, which is great. So we know we're 100% correct at this point. And again, you don't need to do these steps down here, it's just to double check. In case you might have made a mistake, you can go back and double check it. This will get you a merit, this part here. Part D, an equestrian jump has a parabolic arch mounted on a wall. Horses and riders jump through the arch. The arch rises 2.43 meters above the wall. When they're in bold here, just imagine they're yelling at you, because this is usually probably pretty important. The arch can be modelled by a function of the form h of x equals kx times 3.6 minus x, where k is a constant, h meters is the height above the wall. So it looks like everything that they're talking about is from the top upwards, and x meters is the horizontal distance from Q. So the best thing you can do with these sorts of questions is draw the graph, not draw the graph, draw the axes around the picture. So it's saying that x starts at Q, and then you're going to have your vertical axes up there. We know that everything's from the top of the wall because if they're above the wall. So that's our x axis, and that's our y axis up there. Right, we're told the competition rail was placed 0.5 meters above the wall, so we'll write that in 0.5. How long is the rail AB? So we'll start just to get a feel for where the x-intercepts for this graph are based off the equation. So we've got h of x equals kx times 3.6 minus x, and we know x-intercepts occur when y is 0, so h of x is our y in this case, our height. So let's have a look, set it to 0, find out what our x-intercepts are. So what x values make this true? Well, if this x value was 0, then this bit would be 0 times anything, and that would equal 0, so that's one of our solutions, x is 0. And if 3.6 minus x was 0, then we'd have kx times, and then this would be 0, and that would make 0. And what's going to make 3.6 minus x be 0? It's when x is 3.6. So we've got x-intercepts of 0, so that's when x is 0 there, and when x is 3.6, that's the other point where the arch goes back into the wall. Right, what else are we told? So the arch rises 2.43 meters above the wall. So that will be the maximum height of the arch. And so therefore that height there is 2.43 meters above the wall. And because all parabolas are symmetric, and that's the highest point, it must lie between 0 and 3.6, halfway, and the halfway point between that is 1.8. And I'll just show you how to get halfway between a number in case you're unsure. So So halfway between a number is you add the two numbers together that you want to find halfway between. So in our case it's the 0 and the 3.6. So 0 plus 3.6, and then you divide it by 2. And there's our 1.8, our halfway between. Right, why is this useful? Because now we have a point on our graph here saying, well, when x is 1.8, y is 2.43, and that's the information we're going to use to help us find this missing value k in the formula. Then we'll have a formula for any point on this parabola, which we can use to start looking at the rail. So let's put that in. So we've got h equals kx 3.6 minus x, and we said that, well, h is 2.43 when x is 1.8. Just going to chuck the x's in as 1.8. So 2.43 equals k, and 1.8 times 1.8, because that's what 3.6 minus 1.8 simplifies to. I'm going to need my calculator here. 1.8 times 1.8. So I've got k times 3.24. So 2.43 equals 3.24k. And to get k on its own, I'm going to divide this side by 3.24. So they cancel, and then divide this side by 3.24. And therefore k is equal to 2.43 divided by 3.24. 3/4, 0.75, which is the same as, and if you want the fraction equivalent, you click the FD button down here, so just go between them, so it's 3/4. Right, I'm probably going to leave it in decimal form. So now our full equation for that parabola that we can use is the height at any value of x equals k, which is 0.75, and then times that by x, and it's times by 3.6 minus x. Right, so we've got the full equation of the parabola out now. Let's see how we're going to use it to get the distance of the rail. Right, so we've got the height of the rail, and if we can find the x locations, then we can look at finding the distance of the rail. So let's just first find the x location here for this part, and the x location here for this part. And the x locations for this part is when y is 0.5. So we're going to go back to our equation we got. We want x when y is 0.5. So when the height is 0.5, what is x? So all I've done here is just set the height to 0.5, and now we're going to go about solving for x. I'm just going to times both sides by 4 here, so I don't have decimals everywhere. So I'll show you how that works. I'm going to times this side by 4, and then times this side by 4, like all of this, and this side. Right, simplifying that down, 4 times a half is 2. 3/4 times 4 is 3. And then I've got my x times, and then I've got my 3.6 minus x times to that. So now the number's just a lot nicer. Right, from here I'm going to expand the bracket. 3x times 3.6 is, I'm going to check that, 3 times 3.6, so 10.8 x minus 3x times x is 3x squared, we've got a quadratic because the highest power is 2 on x. So as soon as we get a quadratic, we need to set one side to 0, then we can use our quadratic solver, completing the square, or you can use factorization. I'm just going to use the quadratic solver. So I'm going to add 3x squared on this side and minus 10.8x on this side, which means I need to add 3x squared here and minus 10.8x here, and I've got my plus 2 still. So I'm going to have the right's going to be 0 and the left's going to be 3x squared minus 10.8x plus 2. And now it's in the form of ax squared plus bx plus c equals 0. And we can chuck that into our quadratic solver. So our a is 3, our b is negative 10.8, and our c is 2. So to get that on your calculator menu, go down to equations, polynomial, f2, and the highest power we've got is 2, so it's degree 2 on, so it's f1. Right, chucking our values, a was 3, b was negative 10.8, and c is 2. And we get x values of 0.1958, and we expect two values as the bar crosses through the arch twice, and x is 3.4041. So I'm just going to sketch that graph over here so we can have an idea of what we're trying to do and how we can use these numbers to get the length of the bar. So that was our height, or our y, height h. We've got our x. The arch started at the origin and came up, and then it went back down, and its other x-intercept was 3.6. And I'm just going to draw the bar up a little bit higher just so it's clearer to see. But when we were at a half meters high above the wall, we had this bar, so we'll draw it in green. This bar that runs from here all the way across to here. And what we've just found is the x coordinates of the bar. So that one there, that x coordinate at that height was the 0.1958, and so that's the coordinate for that one. And the coordinate x coordinate at that height there, I'm just going to write the number there, 3.4041. Right, so how do we get the length? So what we've got is the length out from here to here is the 0.1958, and the length from here all the way out to here is the 3.4041. So the length of the green part, or the bar, must be the difference between these two lengths. So length of bar is the 3.4041 minus 0.1958, and that gives us, when we calculate it through, 3.4041 minus 0.1958, 3.2083. 3.2083. Let's just check the units of what we've got here. Yep, it was meters, so meters. And if you manage to get that answer out there for the length of the bar, you've just got yourself an excellence. Well done. Part E. Interest is compounded on a principal investment, $P, at the end of each year. If the total amount of the investment after n years is A dollars, then A equals P times by 1 plus R over 100 to the power of n, where R% is the compound interest rate per year. Anushka invests $20,000 at an interest rate of 3.85%, so A equals P times 1.0385 to the power of n. So they've given you the equation there. They've put the R value of the 3.85 up into here, and that's how they've gotten this part here out. So they've been nice and given you that. How many years will it take for her investment to be worth $25,000? Right, so we're going to look at finding P first. Now P is just, for all these equations, always the initial investment, the initial amount. I'm just going to show you why it is. So the reason it is because she's invested $20,000 at the start. She's initially invested it, so when time was 0, remember n is time, she has invested, or her amount, A, will be $20,000. So when she's put this money into the bank or wherever she's investing it, initially she'll have the amount she put in there because there's been no time to get any interest on it. So we put that in our equation here, this one. A is 20,000 when n is 0. And anything to the power of 0 is just 1. So it's P times 1 is P. So therefore P is 20,000, which is the initial investment. So we can rewrite our equation out now as A equals 20,000, because we found that to be P, multiplied by 1.0385 to the power of n. And we want to know how many years will it take. So years is the n value. We need to find n when her investment is to be worth 25,000. So when A is the amount she has, that's the 25,000. So we're going to set A to 25,000 and find out what n has to be to make this true. I'm going to start by dividing both sides by 20,000, just to get that out of the way. Dividing the right by 20,000 will cancel these two out, and then I'll have to divide the left by 20,000, which will leave us with, we'll just check that, 25,000 divided by 20,000, that's 1.25. And that's equal to our 1.0385 to the power of n. And I'm just going to move up here. Oops. 1.25 is equal to 1.03. Just going to write that over here for more space. Right, when you have a variable such as the n that we need to find and it's on the power, the first thing you should be thinking is, how do I get it down? And it's going to be with logs. So to get a log involved, I'm going to have to log both sides to keep it balanced. So I'm going to log the left and log the, so log the right, log the left. Now a log allows us to pull a power to the front, like so, and it's still the same. That's just the property of logs. So now I've got n times by log of 1.0385 equals log of 1.25. Now just remember, with logs they have different bases. Logs can have different bases, so it's important to note that when you log one side and the other side, you've logged them with the same base. The base we're going to use is base 10, as that's one of the only ones on the calculator that they have is log base 10 or log base e. So we're just going to go with log base 10. And our final step to get n on its own, we need to divide the right by log of 1.0385, and that will cancel with that, and then we need to do the same on the left. 1.0385, and therefore n will equal, and we'll just chuck that on the calculator. So we've got log of 1.25 divided by log of 1.0385. So we've got 5.91 years there. Now remember, at the start of the question it did have in bold at the end of each year, so this investment doesn't get any interest on top of it until the end of the year. So our calculation said 5.91 years will give it, so that means it actually doesn't get compounded until the end of the year. So it's actually going to be the whole value number that's closest that'll work is 6 years. Alright. And so if you get that out, that will give you a merit for this question. Remember, you can check your answer too, so we'll just show you how to check it. Remember, from the start, A was equal to 20,000 because that's what we got for P. 1.0385 to the power of n, and we're saying when n is 5.91 we should get an A value of 25,000, so if we plug that n value into there we should get 25,000 out here. So we'll just check that. So 20,000 times 1.0385 and to the power of, and our n was 5.91, and we get 25,003. So it's roughly 25,000. The reason it's not exact is because we've rounded our answer, so that's good enough. And again, you don't need to do this step up here, that's just to check it's right, because if it isn't right you can go back and fix your mistake. Part 2. Semi-C invests his money at a different interest rate than Anushka's investment. So remember, the interest rate that you're investing at is the R value, so we don't know that this time, whereas we did before in the first part. His investment will double in value after 12 years. So n is our time, and we know that n is 12. And his investment's doubled. So we'll look at that soon. What is the interest rate? So what is R for Semi-C's investment? So let's just write down the general equation for this. So that's the one up the top here. So we've got A equals P times 1 plus R over 100 to the power of n, the time. Right, so again, remember that P we found from the part 1, P is just the initial investment, and we proved that up. We showed that up here. So P is the initial investment, so that means that if P is the initial investment, then A, the amount he needs to be double the value. So if his initial investment's P, A will be 2 times P. Just 2 times whatever the initial investment was, because we don't actually know what it is, so we'll just call it P. And we want to know when the amount he's got is 2 times that initial amount. So it looks like we can't find P, which might be a bit of a worry, but we'll just chuck in what we've got for starters to see if that helps us in any way. So what we've got, A needs to be 2 times the initial investment, so 2P. P is the initial investment. 1 plus, now we don't know R, that's what we're trying to find, so that's fine, to the power of, and in 12 years, so n is 12. So we look here and we still sort of look like, well, we've got P on both sides, but we still have it and we don't actually have a value for it, so that could be a problem. But we're just going to show you this, which will clear that up shortly. If we start by dividing the right hand side by P, you notice that the the p's will cancel, so that's fine, they're gone there now. And because I've divided by p on the right, I also have to divide by p on the left. And you'll notice that they completely cancel out on both sides, so now p is no longer a problem, which is great, because now we can start to solve it. We've only got the one unknown, which is r. So 2 is equal to 1 plus r over 100. Which is quite cool, really, because we don't actually need to know the initial investment at all, and we can find out this amount, this percentage. Right, from here, you may be tempted, because you've got this power of 12 up here, to use a log, because it's a power, but remember, you only use logs if you have the thing you're trying to find as the variable, or as the power. 12, you don't need to find 12, it's just a number. So to get rid of 12 as a power, we need to take a 12th root, but we're going to use powers, so we need to take a 1/12th root, and then we need to take a 1/12th root on the left. Remember, these powers will times together, the 12 and the 1/12th, and 12 can be written as 12 over 1, so you've got 12 times 1 is 12 on the top, 1 times 12 is 12 on the bottom, which is just 1. So we're going to be left with 1 plus r over 100 to the all to the power of 1, which is just itself, so we don't need that bit in there anymore. And we've got 2 to the power of 1/12th on the left, which we'll just leave like that for now. Right, on the right hand side, I'm going to subtract 1 on the right and subtract 1 on the left. 1 minus 1 becomes nothing and leaves me with r over 100. And on the left, I've got just 2 to the power of 1 over 12 minus 1. Now I can't go 2 minus 1 because I've got a power up here, so I'd have to calculate that bit first, so we'll just leave it like this for now and calculate it at the end. Final step, I need to times this by 100 over 1, which is just 100. They will cancel, and because I've times the right by 100, I need to times the left by 100. And you could write it as over 1, but we don't need to because there's no fractions there. It's just helpful with fractions to see what goes where. Alright, so let's write it out. So we've got r equals 100 multiplied by 2 to the power of 1/12 minus 1, which equals 100 times 2 to the power of 1 divided by 12, 1/12, minus 1, close the bracket, equals 5.95 to 2 decimal places, 5.95%. So that is the interest rate that Semi-C must invest his money at to be able to double his original investment after 12 years. Right, and that will get you an excellence for that part there. So well done if you got that. Thanks for sticking through to the end of this video. I'll try and start on question 3 as soon as I can. Again, thanks for watching.